Hi everyone, let's see the concept of functional dependency preserving. Guys, basically when we have a relation with the name R having the attributes A1, A2 and so on, an attributes are there in the main relation. After applying some kind of normalization, suppose you got the relations as R1, R2, R3 and so on, Rm relations suppose you got, right? So before going for the actual implementation of this particular database, you have to check various kind of things, right? So among those, what is the first one? You have to check first attribute preserving, right? So attribute preserving means when you are going to have subrelations like R1 having set of attributes and R2 having set of attributes and so on, Rm having set of attributes, when you are going to make them union, the set of attributes what you are getting should be equivalent to the actual relation attributes. This is what I can say that attribute preserving. Okay, for example, if I say there is a relation called a railway relation having the attributes are ABCD, if I am going to decompose into train where the attributes are A comma B, another relation as passenger having the attributes are C comma D. Now, is it an attribute preserving or not? It is going to be attribute preserving. Means how I am saying, by simply taking the attributes of the train relation and the attributes of the passenger relation, if these two are equivalent to the actual relation A, B, C, D, then I can say that this particular decomposition having attribute preserving, right? Yes. And the second one you have to check, that is lossless decomposition, right? So lossless decomposition means when you are going to decompose a relation into R1, R2 and so on Rm relations, again when we are going to perform natural join open of on all the subrelations, you need to get the actual relation, then I can call it as lossless decomposition, otherwise I can call it as lossy decomposition. This is also we have to follow. The another thing is you have to support functional dependency preserving. That is what we would like to discuss in this particular class. But the concept is here, this is an optional one. Means before going to implement the set of decomposed relations in the actual database, these two has to be compulsory satisfied. Attribute preserving and the lossless decomposition have to be compulsory satisfied. Coming to third one, which is an optional one. Okay. So what does the meaning of functional dependency preserving? Guys, you know the meaning of functional dependency. If I am saying that x determines y is a kind of a functional dependency, right? So here they are saying that these also should be preserved, meaning that if the relation R is there, it is going to have some set of functional dependencies. I can call it as F, and for this relation there are many subrelations are there after decomposition like R1, R2 and so on, Rm. For each and every relation you are going to have set of functional dependencies. I can call it as F1, and for R2 I can call set of functional dependencies as F2. For Rm I can call set of functional dependencies as Fm, right? So the meaning of functional dependency means F1 union, F2 union and so on, union of Fm closure is equivalent to F closure. So this is what I can say that functional dependency preserving. See here guys, so here the point is it's not an equivalent, it should be satisfied. Equivalent means what? Like if I say two functional dependency sets are equivalent, F and G are two functional dependencies are equivalent, then it has to satisfy that F should be covers G and G covers. This is what I can say that equivalence. But here I am not saying about equivalence. Whatever the functional dependencies that are there in the actual set of functional dependencies, those should have to be preserved in sub-relational functional dependencies also. Then I can call it as FD preserving, right? So if you want to have clarity, more clarity, we'll take one simple example so that you will get clear idea. Okay. For example, find whether given FDs are functionally dependency preserving or not, right? So they have given a relation with attributes are from A, B, C, D, E, F, G, H, I, J, and you have to have a set of FDs. So they are calling it as F, and their FDs are AB determines C, A determines D, B determines F, F determines GH, D determines IJ. And the set of decomposed relations they mentioned as capital D, and the decomposed relations are ADE, DIJ, BF, FGH, and the last relation is ABC. So guys, so they have given clearly the relation R with a set of functional dependencies and set of decomposition relations. We have to define whether it is FD preserving or not. Can you tell whether it is attribute preserving? Attribute preserving. See, attribute preserving means what? The relation, first relation R1, R2, R3, R4, R5 union attribute should be equivalent to actual relation, right? ADE, DIJ union, BF union, FGH union, ABC, right? So if you are able to observe, this will lead to all the attributes of the actual relation A, B, C, D, E, F, G, H, I, J. Lead to, right? So I can say that which is clearly satisfying the property of attribute preservation. Similarly, can you able to find whether it is lossless decomposition or not? Right? So lossless decomposition means basically we can go with the two approaches. One is through a basic approach of intersection method, another one is through like tabular method, right? So for time being, to define whether it is lossless or lossy, I will go with the intersection method, right? So for example, if I take ADE and DIJ, the common one is here D. If I find out D closer, I am going to get DIJ. So which means that, which is clearly defining one set of attributes of the relation. So I can combine them into a single table. So I can get as ADEIJ. Now, can I combine it with BF? No. FGH? No. Can I combine with ABC? Try to do. If I find out A closer, you are going to get ADE. From D, you can get IJ also. So you are able to get one relation. So I can combine them into a new relation as A, D, E, I, J, B, C. Now can I combine with B, F? Try to do it as B is a common one. Try to find out the B closer. B closer is B, F, which is determining the new relation. Yes, B, F. So I can combine them as a single relation. So A, B, C, D, E, F, I, J. Now the leftover one is FGH. So try to combine with FGH. So what is the common one? F is the common one. So we can able to find out F closer. F closer is FGH. Right? If I are able to find out F closer FGH, I can say that F is a kind of a candidate key. So now I can able to combine as a single relation A, B, C, D, E, F, G, H, I, J. So this is my final relation, right? As the final relation contains the all the data which is equivalent to the actual relation. So I can say that this is lossless decomposition. lossless decomposition. Similarly, according to the question, you have to check for whether FD preserving or not. Let us check, right? So guys, if they are asking for whether FD preserving or not, first you have to find out the set of functional dependencies which are possible for the relation R1, right? What is the relation R1? The relation R1 is ADE, guys. R1 is ADE. When the relation R1 is ADE, now can you define the set of functional dependencies which are possible for the functional dependency set F? Define them. Is it possible with, so how can we do this, right? So you can able to get the functional dependency which are with small a, which are with small d, which are with e, as well as the set of FD is possible with AD, AE and DE. The set of FD is possible with ADE, right? So you can able to do that, right? If I am going to take A, means is there is a possibility of defining FDs with respect to A for this relation. Am I right? So how can we calculate the FDs for a particular attribute? So I can simply calculate its closure. So I hope you know, right? So means if you are going to find out the closure of a particular attribute, I can say that they are going to be generate various kind of additional functional dependencies, right? So if I are able to find out A closure from this one, you will get A, D, E. From D, I can get I and J, right? Is there any other things are possible? No, right? Guys, if you are able to observe here, the meaning of this one is from A with respect to A attribute, I can able to determine A, I can able to determine A, or I can able to determine D, or I can able to determine AE, or I can able to determine AI, or I can able to determine AJ, or it can be a kind of other combinations also, or other combinations like what? ADE, AIJ, like that, right? You know, right? You know all this meaning, right? So what we can do now here, if you are able to observe clearly, here we can able to eliminate certain kind of conditions. What are those? See guys, we are not worried about the trivial functional dependencies, right? We are not worried about the trivial functional dependencies. They are always satisfied. And as we are trying to find out the set of additional functional dependencies for the relation ADE, do we consider I and J? We should not, right? Because A cannot able to determine I as I is not present in this relation. We cannot able to determine J as J is not present in this relation. So I can able to eliminate these two as well as this one. So the set of functional dependencies which are possible for A, or A can determine DE, guys. A can determine DE. Similarly, you have to find out the B closure. Meaning that is there any chance to have the possibilities for D or not, right? Here it should be right. If you are able to find out D closure is D, I and J, right? So any other things are possible? No. And if you are able to write here, it can determine only D, meaning the trivial functional dependency. We are not bothering about this one. So there are no functional dependencies which are possible with respect to D for the relation ADE. Okay, fine. Now can we able to find out E? Yes. If you are able to find out E closure, you will get E, and any other functional dependencies are possible? No. Right? So we completed with one level attributes. One attribute, right? Next, we can able to find out the two level attributes, right? So two level attributes possible are AD, AE and D, right? If you are able to find out AD closure, you will get A along with that D, and from D I can get IJ, from A I can get D, D already there, so I can get D. If you are able to observe guys here, AD is the like trivial functional dependency, I and J are not in our relation, E is there in our relation. So the functional dependency possible here is AD determines E. AD determines E, right? Similarly, if you are able to find out AE closure, you will get AE. From A you can get DE. Very good. From D I can get IJ. Right? So now I and J are not in our relation, so I can eliminate. AE is the trivial functional dependency, so I can eliminate. Right? So from AE I can able to determine. This is one more FD possible for this relation from the given functional dependency. Similarly, if you are able to find out DE closure, you will get DE. From D you can get IJ. Anything are possible? No, right? So this is a kind of a trivial, and these two are not possible. So DE closure cannot determine any new kind of FD. Okay, fine. Now 2-level attributes are done. Next, 3-level attributes. Guys, if you are able to observe, is it necessary to find 3-level attributes? No. The reason is, if you are going to take out the ADE closure, it is going to definitely determine ADE. This is a trivial. From ADE you are going to get other things, but those other things are not in our relation, right? So there is no other 3-level attributes are possible, right? So now simply I can say directly the set of FDs possible for the relation R1. I am calling it as F1. So those relations are A determines DE, AD determines E, AE determines D. Similarly, we have to find out the set of FDs possible for Dij, BF, FGH, ABC. Right? So let us do that. Yes, guys. So these are the set of FDs which are possible for the relation R1. Right? Now try to find out the set of FDs which are possible for the relation Dij, that is R2. Guys, if you are able to find, so we need to find out D closure, we need to find out I closure, and similarly we need to find out J closure. If you are able to find the D closure, we may get D, I and J, DI and J. So which means that, so this is a kind of trivial functional dependency, and I and J are possible. So I can say that D determines Ij is one kind of FD possible, right? Similarly, if you are able to find out I closure, you will get only I. So there is no new FD possible. Similarly, for J closure, if you are going to find, you are going to get only trivial functional dependency. So we can able to eliminate this one. Similarly, what might be the 2-level FDs possible? I can take DI, DJ, and IJ. If I am going to find out DI closure, you can get DI determines J. For DJ closure, DJ determines I. For IJ closure, you are going to get only IJ, right? So I cannot able to consider this. Similarly, if you are going to find out the 3-level attributes, Dij closure, you are going to get definitely Dij, but no other new attributes are possible. Even if it is possible, they are not in our relation. So we can able to simply skip that, right? So the list of FDs possible for the relation R to R, D determines Ij, Di determines J, and Dj determines I, right? So I can write separately as F2, where I can get D determines Ij, Di determines J, Dj determines I. Good. Next, try to find out the set of FDs possible for the another relation R3, that is B, right? So we can able to define the set of FDs which are having B as a FD, right? So B closure find. If you find the B closure, you are going to get B determines F. It is one possibility. Similarly, if you find F closure, you are going to get only F. So meaning that this is trivial, we can simply skip, right? If you are going to take the BF closure is BF. Even if you are going to get any other things, we can simply skip this one. So the set of FDs possible for BF relation is B determines F. So F3 is B determines F, right? Similarly, find the FDs possible for the another relation R4 FGH, right? So for FGH, you have to find out F closure. F closure is determines FGH. Good, it is possible. And any other things are possible? No. Similarly, find out G closure. G closure is G and H closure is H only. So these two are not going to be the new functional dependencies because these are trivial. Because trivial are anyways always going to satisfy. Similarly, if you are going to find out FG closure, you can get one functional dependency as FG determines H. If you find out FH closure, FH, guys, how you got FG determines H? From F you will get GH. FG is the left side, so you can get the right hand side. Similarly, FH closure, you are going to get FH determines G. Similarly, if you find out GH closure, you are going to get GH only, so we can able to eliminate this one. Similarly, if you go with the 3-level attributes, you are going to get anyway 3 attributes, but other things are not there in the relation. We can simply skip this one. So the set of FDs possible for this relation are F determines GH, FG determines H, and FH determines G. So I can call them as F4, right? F determines GH, FG determines H, FH determines G. Fine, right? Try to find out the set of other FDs possible for the relation A, B, C, right? So if you find out A closure, you are going to get A, D, E, and from D you can get IJ and nothing is there, right? But if you take this is a trivial and these two are not in our relation, these are not in our relation, so A closure is nothing is possible. Similarly, try to find out B closure. B closure we are going to get BF, from F you can get GH, so these are all not on our relation, so I can able to simply skip. Similarly, try to find out C closure. C closure is only C, so it is trivial, you could not add this one, right? Similarly, try to find out AB closure. If you find out AB closure, you are going to get AB determines C. This is one of the things possible, right? From B you can get F, all those things, but anyway they are not going to be available in our relation, right? Similarly, try to find out AC closure. Find out AC closure, you are going to get AC only, trivial, so you can able to simply skip. BC closure, you will get B, C, F, G, H, and so on, right? Not and so on. You can't get any other things. Even these two are trivial, these are not in our relation, so you can able to simply skip this one. Okay, means the set of 2-level attributes are done. Now try to find out the set of 3-level attributes, right? You will get ABC and you may get many other, but many other may be possible, but those are not definitely in our relation, so I can able to simply skip this one as this is also trivial one. Guys, as it is first example, I am trying to explain everything in clearly in step by step, but when you are trying to do by yourself, no need to do this much process, right? You can just simply do with as much as our experience have, right? Okay, fine. So the set of FDs possible for F5 relation are AB determines C. Now, is there any other relations are there? No. All 5 relations are done. 5 relations are done. So that's why you got F1, F2, F3, F4 and F5 relations. F5 FDs. Okay. Now, they are asking for whether it is FD preserving or not. Meaning that you have to check whether F closure is going to be possible with respect to the F1 union, F2 union, F3 union, F4 union, F5 closure or not, right? So you can do simple thing, you can just like this, you can just, right? So first take out the first FD, AB determines C. Is AB determines C is possible in one of the sub functional dependencies? Yes, it is satisfied. Next, A determines DE, is it satisfied somewhere? Yes, it is satisfied. Similarly, B determines F, yes, it is satisfied. F determines GH, yes, it is satisfied. Next, D determines IJ, it is satisfied, right? If you are able to observe, right? So as all the FDs are satisfied from which are in the main relation, I can say that this is FD preserving. So I can definitely go with the implementation part, right? But anyway, this is an optional one. Right? So whether it is like FD preserving satisfying or not, they are not going to bother. Just it is a kind of optional, right? If somebody asks you to check whether it is FD preserving or not, you have to go through this particular process. Okay, I hope I understood clearly.